Okay. Well, thank you all for coming. My name's Stuart Herbert, and I've come to talk to you about 5 patterns for improving application robustness. As it's a small audience, this is going to be not just me stood up here talking, it's going to be quite a two-way thing. I'm going to be throwing questions out to you. So the more you participate, the more you'll get out of tonight, I hope. Hopefully this mic will pick you up, so we'll be able to hear you on the video as well. First time I've tried this setup, so fingers crossed. Right, so let's start by explaining why I'm interested in robustness. Where am I coming from with this? And why do I care about robustness? Sorry, can everyone see the screen? Am I in the way of the screen? Right, sorry about that. Unfortunately, I brought my clicker, but it's one of these new Macs, and the clicker isn't compatible with USB-C. Yeah, modern technology. Okay, so when I graduated from university, my first job, I was hired to fix something called NQS. Anyone here got an academia background may have heard of NQS? Nope. Don't worry, it's back in the mists of time. It stands for Network Queuing System. It was originally created for NASA, I believe in 1985. And back then, multiprocessor machines were rare. If you were lucky, there was one on campus, and it was the size of a vending machine, or two. It was a huge thing. And everybody in physics, mathematics, anyone running any sort of simulation or models needed to rent time on these huge behemoth boxes. They were incredibly expensive. They were often as much as 50% or more of a budget for the university, for their IT budget. They were enormous. They had like 4, sometimes 8-core CPUs. A lot of you will have phones with almost that many cores these days. And those phones will be hundreds, if not thousands of times faster than these old computers. So time on these machines was very precious. So NASA had this system built to manage this time called the Network Queuing System, because they were anticipating being able to use cheap unit workstations when they weren't being used on an evening when everyone goes home, to put jobs on there, do a bit more computation, and move them back onto the central mainframe and the central Unix box during the day when everyone was sat at these terminals. And that's what it did. Now, these computations could take months to run. And if NQS crashed and it was managing these computations, the computation crashed and they had to be started again. Can you imagine what it'd be like losing 2 months' work and knowing you have to have another 2 months plus in order to get that work back? There's nothing you can do about that. So robustness there mattered a lot. And it's fair to say NQS was plagued with robustness problems. And eventually it got open sourced through Monsanto. And they fixed it up, and they did a great job of getting it working for them. And we wanted to use it across UK universities to save lots of money, take advantage of all the Unix machines that were starting to come into universities late 80s, early 90s. And so I was hired, and I spent about 22 months trying to make this thing more robust. That was my day job, coming in every morning, fixing bugs. I don't think I added a single new feature that I can recall. If I did, I certainly don't remember it. I just remember the daily grind of getting this thing solid. And afterwards, I maintained it on a part-time basis through till, I think my last patch to it was either 1999 or April 2000. Certainly no later than April 2000. Yeah, lots and lots of bug fixes. So that was the start of my career. And ever since then, I've been involved in doing more and more robustness work. In fact, my company, which is my company, what we do is we're a quality practice. We go in and we help people improve the quality of their code. That's what we do. And recently, I got to do this with the MOT system. I don't know how many of you know. Did you know the UK's MOT system runs on PHP? Yep. If memory serves, it was one of, if not the biggest government IT project over the last few years. And part of that system handles payments. Because when you take your car into the garage to have an MOT done, the garage has to pay a fee to the government. It's called an MOT slot. It's like a license fee to say, yes, OK, I've done an MOT. I owe you some money. And all that money goes through a central payment system called CPMS. And one of the things I did with that was take it on board. It was already existed. Just come in, improve its robustness. And frankly, I did get to add new features to that, which was nice. and establish some practices as well, so that when I left the project, and I've not been there, I left September last year, no, August last year now. So coming up for nearly 12 months. And I left, but I put practices in place, the practices you're going to see tonight, and it allowed the development team to carry on through till Christmas to finish off the development of all the new features without me there, and they were still able to deliver reliable, robust code. These practices work, and they work even when I'm not in the room, which is awesome. But there's a third reason, and this is the reason we picked this talk. Because originally, I think we had 5 or 6 topics up for a vote. And then, how many of you have seen the visual debt video from Laracasts? No? Oh, wow. OK.
A lot of rants on Reddit about it.
Yes, there's been a lot of rants, but it did provoke a very strong reaction, shall we say. And I'm going to, for those of you who haven't seen it, the Laracasts team basically advocated, it was a 3-minute long video, and the original version of the video, they went through and they deleted type hints everywhere, they deleted interfaces, they deleted public, protected, private everywhere, so there was as little code as possible on the screen. And they called it visual debt. All this extra stuff they deleted, they called it visual debt, and suggested that by removing it, you'd make your life easier. Hence the strong reactions. Yep. So when I saw that video, it was like, that's a no-brainer. This is the talk to give. This is the right time to give it. So that will be where we finish. We'll come back to that video at the very end. We'll look at the practices I'm recommending and why I've recommended them. And then we'll see how they stack up against what was in that video. OK? All right. So I'm not here to tell you how to do things. Not at all. I've been doing this for a very long time, nearly 25 years. I've been programming for 35 years now. How many of you are 35 or older? Yeah. OK. So I've seen a lot. I've seen a hell of a lot. I've been very lucky with the projects I've done over the years. I've done academia, I've done government work, I've done startups, I've done enterprise, I've done big unicorn stuff. So I've seen a lot. And I'm bringing that experience along. I'm telling you things I've seen that work repeatably. But it's worth noting, I'm still learning. One of the techniques you're going to see in this talk, I've only been using a few months. After nearly 25 years of professional programming, 35 years of programming in total, I'm still learning. I'm still introducing new things to improve how I do things. There will always be new practices out there, practices I've not seen. You may well have practices that I can learn from tonight. We'll find out.